Okay, what is ARM? Everywhere people talk about ARM controller, ARM processor, ARM controller, etc. And again, people say I'm working with ARM Cortex, I'm Cortex M4, ARM Cortex M3. Why ARM is much popular? ARM is much popular because of three reasons. What is the first reason? When compared with all other microprocessors, ARM uses only approximately 1/10 of the transistors. Say for example, if Intel processor uses 100 transistors to complete the job, means with this 10 transistor, ARM processor can complete the same task if Intel processor or Texas Instruments processor using 100 transistors, means by using 100 transistors completing one job. That means having 100 employees completing one task, but ARM can complete the same task without sacrificing the performance with 10 employees. So accommodating 10 employees is less expensive when compared to accommodating 100 employees. So this is possible just because of ARM. So the ARM uses very minimum number of transistors. Then the second interesting thing is, because we have only 10 transistors to complete the task when compared with the other microcontrollers 100 transistors, power consuming by the 10 transistors is very less. That means providing power supply to the 100 transistors and providing power supply to the 10 transistors, so it is 1/10 of the power. So when it is ARM, means it is consuming only very minimum power. And because ARM is advanced reduced instruction set computing machine, which is optimized feature enhances the speed by reducing the propagation delay. The speed is also very high. So to conclude, very minimum space requirement, very minimum power consumption, and very minimum propagation delay. By having all these three concepts, we can say ARM is much popular. So these are three major benefits of using ARM. Low power consumption means what? All the battery operated devices like our mobile phone, every devices nowadays, whatever we are using, they are all battery operated devices. Because they are all battery operated devices, it is mandatory for us to use ARM processor, because ARM processor is the only processor, or ARM is the only solution which consumes only very low power. Look at the last row, all battery operated devices should consume only very low power. Hence all battery operated devices use only ARM mostly. Even in our mobile phone uses Qualcomm Snapdragon chip, which has ARM Cortex A series of microprocessors. Okay, now you can understand the power of ARM. From this slide, the conclusion is ARM processor consumes very minimum power, ARM processor has very less footprint, and ARM processor a lot of advanced peripherals which can perform the operations in very high speed. That's very interesting. Now the question comes, lot of people, there is a big debate, is ARM a processor or controller? Someone of us say ARM is a controller, someone of us say ARM is a processor, someone of us say it is not a processor or controller, some of us will say it is a combination of both microprocessor and microcontroller. Now let us conclude now whether ARM is a processor or ARM is a controller. Okay, so that is very interesting thing, because a lot of people there will be a lot of debate, I believe, I agree, I hope all of you will agree this. Let us conclude. It is time for us to finalize whether ARM is a processor or microcontroller or something else. The concluding message here is, please say that ARM is a processor. Okay, hereafter there won't be any doubt, ARM is a processor. ARM is not a controller. Exactly speaking, ARM is a processor core. It's very important. Core means what? There are a lot of microcontroller manufacturers. These microcontroller manufacturers get the ARM processor core and keep it as a chief minister. That is very important. So that means ARM is not selling even a microprocessor. They are selling only IP cores. So some of the companies who are manufacturing microcontrollers, they are getting the ARM IP core, and they can add their peripherals and they sell it in the market, and proudly they say that my microcontroller has ARM core inside, something like that. So even Texas Instruments is known for its processor, but Texas Instruments are having a TIVA microcontroller saying that my TIVA microcontroller has ARM Cortex M4 processor inside. So ARM has its own nature, own powerful nature of ultra low power, very less footprints, and high performance. Hence, microcontroller manufacturers use ARM as a processor core in their architecture and proudly say that microcontroller. This is the block diagram. Look at the screen. This is the block diagram of LPC2148 microcontroller. In this LPC2148 microcontroller, the highlighted portion is ARM7 TDMIS. That means there is a microcontroller which contains microprocessor, ROM, RAM, parallel port, serial port, timer, interrupt controller, out of which the microprocessor portion is ARM7. That is chief ministry is ARM7. TDMI means what? T stands for thumb instruction, D stands for debugging facilities, M stands for hardware multiplier, and I stands for in systems in-circuit emulation, and lot more. All of us know this. So here, the major important point what you need to understand is ARM is a processor core in an LPC2148, which is Philips company. Now it is NXP. So NXP is a company who is releasing LPC2148 microcontroller in the market, which has ARM7 processor core inside. It is the magic here, so which is being highlighted. So as per our rainbow, there is a need for ROM and RAM. Now look at the screen, and now there is a processor here, and there is a ROM. There is a 512 kilobytes of on-chip flash memory, which is read-only memory, and there is a 32 kilobytes of RAM. There is a 32 kilobytes of RAM. So 512 kilobytes of flash memory and 32 kilobytes of RAM. Look at the screen. So microprocessor, ROM and RAM is there even in LPC2148 microcontroller. So microprocessor is there, ROM is there, RAM is there. The fourth peripheral is general purpose IO. Parallel port is otherwise called as general purpose IO. And again, one more important concept I want to tell you right now is ARM means 32-bit. So there is no ARM processor in the world like 8-bit ARM processor, 16-bit ARM processor. Whenever you utter the word ARM, always you must remember it is a 32-bit processor. That means LPC2148 microcontroller is a 32-bit microcontroller. That means any microcontroller which uses ARM core means that uses only 32-bit microcontroller. That is the mandatory requirement. Hence the port is also 32-bit. So as we all know, LPC2148 has two ports, port 0 and port 1. Port 0 contains 32 IO lines and port 1 contains 16 IO lines because of 48 pins, as we all know. So now let us look at the screen. It's very interesting. After understanding, so this is the data sheet. So when we are developing any embedded system, looking at the data sheet is very important, and looking at the block diagram and looking at the parallel port is very important. After understanding the data sheet, we have to draw the circuit diagram like this. And this is the circuit diagram of one of the LPC2148 microcontroller circuit. So this is the initialization circuit. There are VCC and decoupling capacitors and crystal oscillators and ground, VCC, all those things are connected. After making the circuit, we have to make a board. This is the microcontroller development kit. So this is the microcontroller board, and you can look at the screen here. This is the small square box, which is approximately 1 square centimeter, which is 64-pin quad inline package LPC2148 microcontroller. So this is the microcontroller kit. So for looking at the microcontroller, we need to look at the data sheet. For looking at the board, we need to look at the user manual, as we all know. So by looking at the user manual of this kit is from Rhydolabz, RHYDOLABZ. So there's a board here. This board contains LPC2148 microcontroller, all the necessary peripherals. I'll quickly share about it. So this is again the front view of this board, which has LPC2148 microcontroller behind this LCD. And there are LEDs here. There are LEDs, there are switches, and there are input-output devices as like this. The front portion of the kit, Rhydolabz kit, and the back portion of the Rhydolabz kits, etc. And first and foremost interfacing is LED. If LED blinks, we'll stop blinking, right? So the LED is blinking here. So that means that the LEDs are interfaced with the ARM kit is something like this. LEDs are interfacing with the ARM kit is something like this. Now, let us say the board is ready, and we have to, let us assume that software is ready. Whenever the software is running means how it runs. You can see the LED is blinking. Is the LED blinking? You can see this LED is blinking here, right? Okay, so the blinking of an LED will help us confidence, will give us confidence, yes, microcontroller is in our control. So the first and foremost interfacing must be LED interfacing. Because we talked about a celebration, celebration means what? If you are going for a marriage, no? How do we identify the marriage house? The house will be decorated with a lot of lamps. That's why we blinked an LED. And the second important thing is, if it is a celebration means definitely there will be a song. People will celebrate with by playing a beautiful song. That's why after interfacing LED, we have to interface a buzzer. Look at the screen here. So this is the user manual which talks about the buzzer interfacing. Now let us listen here. Is it possible for you to hear the buzzer sound? Both audio and video. When LED glows, buzzer is not producing sound. When buzzer is producing sound, LED is not glowing. So what is timer? Timer is necessary to produce a time delay. So instead of writing a delay routine, by using timer, we can develop an application code. Here there is no delay routine in the screen. So without any delay routine, with the help of timer, we are blinking, and a lot more interesting things are there. Again, the same blinking is happening here. We talk about pulse width modulation. So before discussing about this, before seeing this video, let us have some discussion about the theory, and then we will come back. Let me go to the slide. to discuss something about the pulse width modulation. Before that, so we have discussed about the parallel ports, and let us look at the serial ports. Let us look at the serial port of this. LPC2148 microcontrollers has 4 different serial ports. Look at the screen. LPC2148 has USB, because USB is much popular nowadays. Any device that we have, it is USB compatible. Hence, it is mandatory for microcontroller manufacturers to keep the USB on chip. Hence, USB is on chip in LPC2148 microcontroller, which has a D plus D minus pin for our understanding. And LPC2148 has I2C bus, because I2C bus is very much important for on-chip, on-board communication, which is clock-based synchronization serial communication protocol, where SDA and SEL are the serial clock. I2C. There are 2 I2C serial bus interfaces are there in LPC2148. And SPI. What is SPI? Serial peripheral interface. Serial peripheral interface is mandatory for our SD card, because it is one of the high-speed full duplex serial communication protocol. Look at the screen. This is SSP. It is sound. That is SPI is sound. All the memory card uses SPI communication. So a lot of audio video communication is possible just like that, only with the help of SPI serial communication protocol. And most favorite, all of us will celebrate only UART. The most favorite UART is here. So there are 1 USB, 2 I2C, 2 SPI, and 2 UART is there, universal asynchronous receiver transmitter. Okay. So there is a parallel port and serial port. Serial ports, there are 4 different types of serial ports in LPC2148. There is a conclusion. And as we all know, there is a max 232, which is a voltage level converter, because if it is a max 232, plus 12 and minus 12 are the voltage, and 3.3 is the voltage. To convert the voltage from 3.3 to plus 12 and minus 12, and plus 12 minus 12 to 3.3, this max 232 is there. And there is nothing with the timer here, and there is something like an external interrupt here. So microprocessor, ROM, RAM, parallel port, serial port, interrupt controller, and there is something like real-time clock. Okay, let us look at real-time clock. It's very interesting, right? Real-time. So real-time embedded system is our title. Real-time embedded system is our title. Hence, I'll take some time, few minutes to discuss about what is real-time. Okay, let us spend some time for real-time. So the next celebration. What is real-time? The first question. So quickly to say, if the execution time is 100% predictable, then we can say it is real-time. So please try to understand. You must utter the same word. If the execution time is 100% predictable, then we can say it is real-time. Okay, to make it more clear. What is real-time clock? If the execution time of the clock is 100% predictable, then we can say it is real-time clock. Can we justify? Yes, we can justify. Look at the screen. Real-time clock produces 1 second 100% accurately. 100% accurately means 1 second means 1 second. It is not 0.9999 second, or it is not 1.00001 second. 1 second means 1 second. If 1 second is 100% accurate, then 1 minute will be 100% accurate. If 1 minute is 100% accurate, then 1 hour, 1 day, 1 week, 1 month, 1 year, even 100 years is 100% accurate. But I do not know whether we are available to see how the after 100 years whether it is working or not. So all the calendars in our mobile phone, all the reminders in our mobile phone, all the schedulers in our mobile phone, our Sridhar sir has sent you the Google Calendar notification. This is just happening just because of real-time clock. So real-time clock, wherever there is a hours, minutes, seconds, definitely real-time clock is the only solution. So reminders, alarms, calendar, schedules are possible only because of our time. The wristwatch, whatever we are doing, the wristwatch, the wall clock are also working just because of real-time clock, because there is 100% accuracy. And the second wheel and the gear wheel, second wheel and minute wheel and hour wheel in the wall clock are stepper motors. As we all know, stepper motors are the only motors which can give 100% accuracy in open loop control system. Hence, there is no feedback in the wall clock, but it's a stepper motor based control system which works fine 100% accurately, because every step is 6 degree. 60 such 6 degree is 360 degree. The second wheel is directly connected to the stepper motor. Stepper motor is driven by RTC. That means every second RTC, real-time clock, gives a pulse. For every pulse, the stepper motor returns 6 degree, which is our wall clock, which is our wristwatch. Fantastic, right? So all the clocks are working only because of real-time clock. Okay. So the webinar is notified only because of RTC. Similarly, if an execution time in an operating system, but operating system's execution time is 100% predictable, means we'll call that as a real-time operating system. We'll talk about real-time operating system later for time being. Okay. Now the real-time clock means 2 important things which you have to concentrate. Time and tide waits for none. That is a formal thing. So if the power goes off, time should not stop. If the power goes off, time should not stop. So the LPC2148 has on-chip real-time clock. So for that, there is a V battery. There is a, if you look at the screen here, there is a battery. So we need to connect a battery. We need to connect a battery to this, and this diode will charge the battery. This diode will charge the battery as long as there is a power supply. If the power supply goes off, the display will disappear, but the clock will continuously run. So to make 1 second delay 100% accurate, there is a need for a crystal oscillator. So crystal oscillator of 32.768 kilohertz will make the 1 second delay 100% accurately. So I'll show you the video with the real-time clock where you can really appreciate this. Now look at the screen as shown here. If it is a real-time clock, means there is a need for a battery and there is a need for a 32.763 kilohertz crystal. Then you will get a 100% accurately 1 second delay. That is the discussion which is happening here. And the LPC2148 as a real-time clock, as told, we have to look at the data sheet. So this is explaining about how to use the data sheet. Now it is downloaded, the code is downloaded, and UART, through UART communication, we are displaying the time, current time. So this video was taken 1 year before. That's why it is showing the current time. Look at the screen here. It is 14th of 2019, Tuesday, 15, 26, and 36. From this video, I'm going to show you one very important thing. So I have disconnected the power. You see, I have disconnected the power. Once again, I'm replaying for your convenience. So it is showing 14th May 2019, Tuesday, 15, 26, 21, 22. So even in the absence of power supply, with the battery, it has to work. That was the statement I have given, right? So now it is USB powered kit. Now it is USB powered kit. Now I'm disconnecting the USB power. You see. But what is the time now? Which is the screen. What is the time now? Which is shown on the screen? The screen shows 15, 26, and 36 seconds. So when the power comes, it should not start from 36. Even in the absence of power supply, through battery, the clock has to run. 15:26 to 3 o'clock, 3:26, 36 seconds. At least when I reconnect the power supply, it has to display at least 15, 20, 30, 37. See, I'm reconnecting it. I'm reconnecting this power supply, and this is very important. So it is changed as displaying 26:36 instead of 26:37. If you refresh the screen, you can see it is 27:20 seconds. So even though there is no power supply, clock is running. That is the magic. That is the moral we have understand. This is because of the battery in the backside as shown. So because of this battery, even in the absence of power supply, the clock runs. This is the magic we have to remember forever when we talk about the real-time clock, which is very interesting. Okay. I look at the screen. This is very important and final part of our discussion. So look at the screen. It is talking about pulse width modulation here. What do you mean by pulse width modulation? All the linear control in the world, whether it is a volume control or whether it is a brightness control in a mobile phone or a speed control in a quadcopter, all these things, whether it is a motor control or whether it is a intensity control or whether it is a volume control, is happening only and only through pulse width modulation. So with the following slides, I am trying to make you to understand a very simple way how the pulse width modulation is helpful in performing the linear control. What do you mean by linear control? Means varying the voltage linearly. That is the mandatory. If the voltage is connected to the volume increases or decreases. If the varying linear voltage is connected to the LED, brightness will vary. If the linear voltage is connected to the motor, means motor speed will vary. DC motor speed will vary. That's all. So the prime requirement is varying the voltage. That's all. So varying the voltage can vary the volume, brightness, and the speed. That is the only thing which we can understand. As you know, pulse width modulation is represented with the duty cycle. So the first row, horizontal line, 0% duty cycle, here 25% duty cycle, 50% duty cycle, 70% duty cycle. Frequency remains same and the width is changing. That's why it is a pulse width modulation. Look at the screen, it's very interesting. So with this increasing, with this decreasing. So this animation will help us to understand. So this is how pulse width modulation works. And the next animation will help us to understand. Look at the blue color mark. So the average voltage increases when width increases. The average voltage decreases when width decreases. It's very interesting. And now look at the screen. If the width increases, the brightness of the LED increases. If width decreases, brightness of the LED decreases. This is how the intensity contrast control in the mobile phone is also working. So the contrast control in mobile phone is working just because of the pulse width modulation. Now you can see RGB LED, all the three colors, three control. So our Philips Hue lamp or Wipro multicolor LED lamps are working just because of this pulse width modulation. So pulse width modulation is very interesting. So pulse width modulation can be generated with the help of a microcontroller like this. So rest of the thing will theory. So practically speaking, so lab equipment has come. Here the LED brightness control is happening because of the pulse width modulation like this, and speed control of the basic. So do you want to see the pulse width modulation as a celebration. So you want to see the pulse width modulation as a celebration here. Now I'm going for a final celebration of pulse width modulation as an e-bike, because mechanical engineers are the ones you can celebrate this. So I can increase the volume and decrease the volume by using pulse width modulation. Now you can look at the screen here, e-bike. So there is a potentiometer here, and there is a through potentiometer we can increase the acceleration and deceleration, and we can able to hear the voice. You can see, I'll show you. I'm increasing the volume. So when it is 1023, volume is high. That means I am accelerating. When you are decelerating, the value will reduce, and we can get the minimum sound. Observe carefully. When I reducing the potential, when I reducing the volume, means now it is 0. Now there is no sound. You see. Now I am adjusting. Based on the adjusting, the music volume is adjusting just because this is happening just because of pulse width modulation, sir. That alone you can understand. Later on, offline we can do much. So this is the magic of pulse width modulation, which we have to celebrate from this particular slide. And finally, last few slides to celebrate the validatory function here. And there is something like a direction control. So there is a H bridge here. H bridge control helps us to change the direction of rotation. So 1 minute understanding here, right? Changing the direction of the current flow is done by changing the polarity, right? Look at the screen here. If I close the switch S1 and S4, always the current flows from higher potential to lower potential. So the top is VCC and bottom is ground. So the current flows from here and goes into the micro motor like this from left to right. If the current flows from left to right, then magnetization will happen in one direction, and the direction of rotation will be in one direction. So let us say clockwise direction. If I close the switch S3 and S2, the current flow will be in this direction. This will become plus and this will be minus. So the direction of the current flow changes. So direction of the magnetic field will change, hence the direction of the rotation will change. This is very clearly visible in the screen. If the S1 and S4 is closed, it means current flows from left to right. So motor rotates in clockwise direction. If we switch on Q3 and Q2, current flows in the right to left, hence the motor rotates in anti-clockwise direction. So H bridge is a DC motor driver, which helps us to make the motor rotate in both clockwise and anti-clockwise direction. So the conclusion here is, whenever there is a motor, there are two things which are mandatory. One is speed control, another one is direction control. Speed control is achieved using pulse width modulation. Direction control is achieved using, the H bridge. So one very good example, in our car, we have a power window. So when we press one button, motor rotates in clockwise direction, so window comes down. If we press another button, motor rotates in anti-clockwise direction, window is closing. So power window is a very good example. Forever we can remember there is a need for direction of rotation control. If the motor rotates in one direction, window comes down. Motor rotates in another direction, window goes up. So direction control is also mandatory. Speed control is also mandatory for any motor control applications. So speed control is achieved by using pulse width modulation. Direction control is achieved by using H bridge. That is the moral of this discussion. And all our house has a UPS. UPS is converting the DC supply to AC supply only through H bridge. That you need to understand, right? H bridge. By properly switching, we are able to convert the DC to AC. That is the magic of H bridge. And finally, ADC and DAC. So temperature sensor means temperature sensor. Here it is a motor control. So ADC converts temperature into digital value, and a microcontroller makes some decision, and it adjusts the PWM where the motor speed control is. This is a closed loop control system with respect to the microcontroller and embedded system. Our LPC2148 is capable of performing the signal processing also. When it is a signal processing, means microphone will be the input and loudspeaker will be the output. So wherever there is a microphone, there is a need for ADC. Wherever there is a loudspeaker, there is a need for DAC. Hence our LPC2148 has both ADC and DAC also. But there are 7 peripherals. Along with 7 peripherals, and there are so many other peripherals also. So here there is an ADC, and ADC is here, and DAC is here, and a lot more.